Precalculus 5.1, Day 3. So in example 1, we are going to be adding these trig expressions, and in order to add them, we need a common denominator. And so again, on these, you need to start by copying the original problem, work down the page, and when you start on each line, start with an equal sign. Write complete full expressions as you go from line to line. And so in this one, the common denominator is going to be the product of 1 plus cosine theta times 1 minus cosine theta. And so in this first expression, you have 1 plus cosine theta. I'm going to put that in parentheses for communication. And so I'm missing the 1 minus cosine theta in the denominator. So I need to take both the numerator and the denominator by 1 minus times 1 minus cosine theta. That way I'm just multiplying that fraction by 1 and I will not change the value. For the second one, they have 1 minus cosine theta. I am missing the 1 plus cosine theta. So I need to take both the denominator and the numerator times 1 plus cosine theta. Make sure that you have the argument of theta in each expression. And so now, with that, I have a common denominator of 1 plus cosine theta times 1 minus cosine theta. And so then I am going to take and multiply the numerators on the first one. And when I do that, I just have a 1 minus cosine theta. And then I'm going to add to that the product here of 1 times 1 plus cosine theta. So I'm going to have plus 1 plus cosine theta. And then I have some like terms that I can add up. And the cosine theta plus and minus are going to cancel, and 1 plus 1 is 2. And in the denominator, I have this product of 1 plus cosine theta times 1 minus cosine theta. And when I multiply this, I have this a plus b times an a minus b kind of thing. And that comes out to a squared minus b squared. Because again, this would be a squared minus ab plus ab minus b squared, and the middle two terms cancel, and it leaves you with just a squared minus b squared. That's a special product. And so now my a is 1, so I get 1 squared, and then minus my b is the cosine, so I get 1 minus cosine squared theta. And now 1 minus cosine squared theta, remember the sine squared theta plus cosine squared theta equals 1. If I solve that for sine squared theta, I have sine squared theta is 1 minus cosine squared theta, so I can substitute sine squared theta in for 1 minus cosine squared theta. And then we don't want a fraction, so we can simplify that because 1 over sine theta is cosecant theta, and so 1 over sine squared theta is cosecant squared theta. So I'm going to write this to cosecant squared theta. Again, 1 over sine theta is cosecant theta, and so 1 over sine squared theta is going to be cosecant squared theta. All right, example 2. Rewriting it, and we don't want this in fraction form. And so I'm going to start with that, and on the next line write an equal. Well, I know that sine squared, as we saw in the last example, is 1 minus cosine squared theta. And 1 minus cosine squared can factor, it's that a squared minus b squared that factors a plus b times a minus b. So 1 minus cosine squared factors into 1 plus cosine theta times 1 minus cosine theta. So that's where we're going with this. So sine squared theta, I'm going to start one step at a time. I'm going to write 1 minus cosine squared theta over 1 plus cosine theta. Don't factor right away. Take 2 steps to do this. And then 1 minus cosine squared theta factors 1 plus cosine theta times 1 minus cosine theta, all over 1 plus cosine theta. And now we can cancel. Now, one thing I see people doing that you should not do this way is they do 1 cancels with the 1 and the cosine cancels with the cosine. No, that's not the correct way to do this. So I'm going to back up. It is that this as a factor takes out that as a factor. That's how you should cancel those. And you're left with just 1 minus cosine theta. So moving to example 3, we have a trig substitution. We're going to substitute in for x this 5 sine theta. And they're letting us know that theta is a quadrant 1 angle. And so that tells us that all trig functions would be positive. So we're going to start with this 25 minus x squared. We're going to start with that. We're going to work down, start with an equal sign. And we're going to replace x with 5 sine theta. So this is going to become 25 minus 5 sine theta. And that quantity is going to be squared. And remember, when you have two things that are being multiplied and you take them to a power, you have to take each of those to that power. So underneath this radical, I'm going to take 5 squared and get 25, and I'm going to take sine theta squared and write it sine squared theta. Now the trick is to notice that I can factor out a 25. By the way, this is not just 5 minus 5 sine theta. That is not true. The square root of a squared minus b squared is not a minus b. You can't do that with differences or sums. They're not equal. But what you can do is factor out a 25 underneath the radical and have 1 minus sine squared theta. And 1 minus sine squared theta is cosine squared theta. Remember, sine squared theta plus cosine squared theta is 1. And if I solve that for cosine squared theta is 1 minus sine squared theta. So I can replace 1 minus sine squared theta with cosine squared. So now I have 25 cosine squared theta. And when you have the square root of a squared times b squared, assuming a and b are positive, it is just a times b. So with a product, we can take their individual square roots. You just couldn't do that with a sum or difference. So this becomes 5 cosine theta. And so that's what that simplifies to. You need those steps. You need equal signs, and you need to work down the page and communicate clearly and fully. Right, example 4. Use this substitution, and they're talking about theta is from negative pi halves to pi halves. Then find sine theta and cosine theta. So we are going to replace x with 8 cosine theta. And then when I go to square on the right side, underneath that radical, I get 6, whatever that was. I get 64 cosine squared theta, because you have to square both the 8 and the cosine. And remember, that is not 8 minus 8 cosine theta. With subtraction, you can't take their individual square roots and subtract. They're not equal. But what I can do on the right-hand side, notice, oh, I don't know, something that I'm touching here is they're not liking it. So remember, as you work this down, you need complete full expressions. In this case, we had an equation, so we don't put an equal out in front on each line. We have an equal sign within each statement as we work down line to line. Make sure you show that for root 3 on the left as you work down. So anyways, on this, we have 4 root 3, and underneath the radical, I want to factor out the 64, and I get a 1 minus cosine squared theta. Do you know where we're going with this? We have that sine squared theta plus cosine squared theta is 1. If I solve for sine squared, that is 1 minus cosine squared theta. So I can replace 1 minus cosine squared theta with sine squared theta. So I have 4 root 3 equals 64 times sine squared theta. And so now the square root, again, if I have the square root of a squared times b squared, those are just going to be ab. Excuse me. And so I have 4 root 3. It's going to be 8 sine theta. Solving for sine, I have 4 root 3 over 8 equals sine theta. If I simplify that, I have root 3 over 2 equals sine theta. And so it said theta could be from negative pi halves to pi halves. So if I think about triangles in this case, if it's quadrant 1, if theta is between 0 and pi halves, then this y value would be in root 3 over 2. That's one of those on the unit circle that we know. We know that then the x would be 1/2, and theta would be a 60-degree or pi thirds reference angle. The hypotenuse is 1. But if theta happens to be between negative pi halves and 0, then it would be a negative root 3 over 2. But this point would still be to the right 1/2, but down root 3 over 2. And the hypotenuse would be 1. And so we have 2 answers for sine. It says find sine theta and cosine theta. Well, if 0 is less than theta is less than pi halves, then sine of theta is a positive root 3 over 2. However, if negative pi halves is less than theta is less than 0, then sine of theta is negative root 3 over 2. So we've got that answer for quadrant 1, this answer for quadrant 4. Now, in both of these cases, cosine, whether it's quadrant 1 or 4, is a positive 1/2. So when negative pi halves is less than theta is less than pi halves, then irregardless, cosine of theta is always a positive 1/2. And those are my solutions. That's it.